Hello everyone, welcome to the fourth video in the series AWS Solution Arc Certification Sample Practice Questions. In this video, we're going to focus on the database where we'll look into DynamoDB, RDS, Aurora, and Elastic Cache. So let's get going. So this is our first question. A global bank has designed a highly available multi-region application to be deployed in US East and US West region to mitigate against AWS regional failure. Which combination of services can help the customer achieve a high availability in such a scenario? The RTO and RPO of the application should be less than 5 minutes and the database failover should be automated. So these are the three key requirements you have. One, at both app, web and database tier, you need to have an application that can withstand AWS region failure. So that's the one requirement. The second one is that RTO and RPO should be less than 5 minutes and the database failover should be automated. So that's the third requirement. Now let's take a look at what are the options we have. So the first one, use Route 53 failover routing policy to route data between two LBs across two regions. So this will work well. So you have two LBs across two regions and then you have the Route 53 failover routing policy. So if one region fails, then you can shift the traffic to another ALB. So this should be good for web and app tier. Now let's look at the database side. For the database use RDS MySQL for automated cross-region failure. So this might not work because the RTO and RPO for the on the database tier as well is less than 5 minutes. But in case of RDS MySQL, when you have a cross-region replica, there is much larger lag time and RTO and RPO is not possible in this scenario. Similarly, it does not allow for automated cross-region switchover. So if you have a read replica in another region, there's going to be some lag and if there is a regional failure in the primary one, it will not automatically switch over to the read replica in the secondary region. So you have to do that manually. So most of the time an RTO or RPO of 5 minutes will not work. So this option you need to rule out. Now let's look at second one. For use the Route 53 routing policy to route data between two ALBs across two regions. Yeah, so this kind of works. We already discussed that. Use RDS Aurora for automated cross-region failover. So one thing you need to know about RDS Aurora is that the replication lag is usually in milliseconds, definitely less than 1 second. So and the second thing is the failover from one region primary to secondary in case of failure in the primary region happens in an automated fashion. So there is no manual intervention and it can be done in less than 1 minute. So because the lag is pretty low. So this definitely seems like a promising answer. It ticks all the three requirements. But now let's take a look at other options that we have. So use two fixed endpoints of the global accelerator to route traffic to those two ALBs and use RDS MySQL for automated cross-region failure. So global accelerator also you can use. You will get two fixed endpoints and then from there you can route traffic to two ALBs in those two regions, right? Now, so that's that. The first point, it works, seems to be okay. But again, the second one, use RDS MySQL, it will not work because it's not automated and RTO is about five minutes, around 5 minutes or so. So this will not work. Use two fixed points of global accelerator to traffic to two LBs and use SQL installed FSX as an FCA cluster. The cross-region FSX enables high availability on the database side. Okay, so the first one works okay for web app tier, used global accelerator as we already discussed. The second one, it says that use SQL installed on, you install the FSX on EC2 and on top of that you install the SQL database, usually what we call as an FCA cluster. So the good thing about FCA cluster is it is not availability zone specific like an EBS. So it works across the availability zones, but it is limited to a region. So again, so this will not help us in achieving cross-region failure mitigation. So this is not a correct answer. So the correct answer is the second one. Okay, great. Now let's look at the second question. A solution architect at a multinational bank needs to design a relational database in such a way that it is a managed service. Okay, so you have a relational database and some managed service, highly available and can scale read capacity and storage automatically without interruption to the service. So it needs to design a relational database. So what are the key requirements? So it needs to design a relational database. It's in a way that it's a managed service, it's highly available, and you can increase the read capacity and storage automatically without any interruption. There should be no interruption to the service. Okay, now let's look at what are our options. So use RDS. So RDS ticks the box. It's a managed service in a multi-region high availability. Increase the underlying instance size for read capacity and auto scale the storage based on the maximum limit set while enabling the storage auto scale. So yeah, RDS works in a multi-easy, so it will be highly available. Then it can auto scale the storage, so that works as well. But what it is saying is increase for the read capacity, increase the underlying instance size. See, RDS is basically just a database in managed database installed on EC2. But if you have to increase reads and writes, then for writes you have to increase the instance size. But if you increase the instance size, that usually means that there will be some interruption to the service. But here it does not want any interruption to the service, and it does not want any write capacity, it only wants read capacity. So read capacity increase, you can also use the read replica. So this doesn't seem it meets some of the requirements, but not all of them, because there is going to be interruption of the service in case you increase the underlying EC2 instance. Okay, now let's look at the second one. Use read replicas in multi-region for automatic failover to make it highly available and scale vertically. RDS auto scale can be used to increase the storage once the threshold limits are reached. So okay, so the auto scale you can do, but we also need to increase the read replicas. So it's talking about using the read replicas in the multiple regions for an automatic failover. So you can have read replicas in a different region for automatic failover, but that's not what the requirement wants. The requirement is looking to have the read replicas to scale. So it is partially correct in the sense that you will have read replicas across regions. So you might be easily able to scale up with the increasing read request, right? Okay, so it seems partially correct, but let's look at if there is a better option available. Use RDS read replicas in multi-regions for automatic failover and high availability, and increase the instance size for vertical scaling and auto scale the storage maximum limit set while enabling the storage auto scale. So it's saying increase the instance size for vertical scaling. But if you increase the vertical size instance size for vertical scaling, there is going to be a service interruption. So this is not a very good option. Now let's look at the last one. Use RDS in multi-AZ for high availability. Okay, that's good. Use read replicas to increase the read capacity. Okay, that works as well. And auto scale the storage limit based on the maximum set while enabling the storage for auto scale. Okay, so this one seems the most promising of all the four. It provides my high availability across AZs. Then it can increase the read replicas for allowing the change if you have to increase, if there are a lot of read requests. So you can enable it through read replica. There is going to be no service interruption when you add new read replica. And then finally, you can also auto scale the storage when you are reaching the threshold limit. So this is the most appropriate answer. Okay, now let's look at the third question. A multinational bank has highly available and scalable 3-tier application on-premise which needs to be migrated to AWS. The solution architect working on the design chose EC2 instance with auto scaling in the web and app tier and RDS as a database in the multi-AZ environment. However, there are a lot of read queries and the data changes for read queries are minimal. The architect wants to choose an AWS service that can handle the read queries with minimum latency, and at the same time it should be highly available across AZs and recover from failure. Okay, so the key requirements are that it should be it's a 3-tier application, highly available, EC2 instance auto scaling on the web and app tier, and there are a lot of read queries. There is not a lot of change to those read queries, and it also needs the read queries with minimum latency, and at the same time it should be highly available across AZs and recover from failure, whichever service that you use for read queries. Okay, now let's look at the options. The architect can use RDS read replica across AZs and the region to handle large number of read queries and reduce the load on RDS. So yeah, RDS supports the read replica. So that's one of the possibilities. If you have it across AZs and regions, then it should be able to support the read queries as well as recover from failure. So this seems like a good option, but let's take a look at the other option that we have. AWS Redis is a multi-AZ, highly available, fast in-memory cache that can handle read queries and reduce the load on RDS. So yeah, Redis is actually a cache which can be used as a cache in-memory cache and can handle read queries. And especially it says that the changes to the read queries are minimal. So when you're looking to for read queries, when you're looking whether it should be read replica or whether you should use a cache and in-memory cache like Redis or Memcache, the data is changing very frequently, then a good option, and you have a lot of read queries, the good option is read replica. But if you have a lot of read queries and the data is not changing so frequently, then the better option would be either use Redis or Memcache. So there is a possibility of using Redis as well, but the problem here with Redis is that it is not easy to recover from failure. So you cannot have it as multi-AZ, or you cannot have create a snapshot, etc., from which you can recover. So from that perspective, it doesn't seem to be a very good fit. So we'll cross it out. Now let's look at AWS Memcache. Is a multi-AZ, highly available, fast in-memory cache that can handle read queries and reduce the load on RDS. So again, as I said, we have two options for read replica for a lot of read queries, either read replica and or in-memory cache. Here the data is not changing a lot, so we'll have to probably prefer in-memory cache. And so then in memory cache we either use Redis or Memcache, but it wants that the cache should be highly available and recover from failure, which is a characteristic of AWS Memcache. So this seems to be a better option than one, so we'll cross out the one. And then let's look at the fourth option. DAX can be used to offload some of the read queries from RDS. DAX uses a write-through caching strategy to provide better performance and RDS read replica. It is true that DAX uses the write-through caching strategy, but DAX is only used for DynamoDB, not for RDS. So this is an incorrect option. So the correct option is the third one. Okay, now let's look at the question number 3. A multinational bank has a highly available and scalable 3-tier application on-premise which needs to be migrated to AWS. The solution architect working on the design chose EC2 instances with auto-scaling in the web and app tier and RDS as a database in a multi-AZ environment. However, there are a lot of read queries and data changes for read queries are minimal. The architect wants to choose an AWS service that can handle the read queries with minimal latency, and at the same time it should be highly available across AZs and recover from failure. So what are the 3 key requirements? The solution should be highly available, and on the web and app tier it is using EC2 instance auto scaling, so that's already covered. On the database side, it's using RDS in a multi-AZ environment. However, there are a lot of read queries that the database is experiencing, and the architect has to have a service which can help with these read queries and it can handle with minimum latency, and at the same time that service should also be highly available across AZs and recover from failure, right? So these are the 3 key requirements. Now first we have to look at what are the possibilities for handling the read queries in RDS. So there are 2 options. One, you have the RDS read replica. The second one is having some kind of cache service or solution, which can be either Redis or Memcache in AWS. Now let's look at the options. The first one is the architect can use RDS read replica across AZs and regions to handle large number of read queries and reduce the load on RDS. Yeah, that's definitely a possibility. You can use RDS read replicas across AZs and regions to handle the read queries. So this seems to be a good solution, but let's look if there are any better solution than this. So AWS Redis is a multi-AZ highly available fast in-memory cache that can handle read queries and reduce the load on RDS. So this is also a good solution. So Redis provides you with ability of an in-memory cache that can handle the read queries. It is also multi-AZ and highly available. And it also provides you the option of recovering from failure automatically. So it seems to tick all the boxes. So this is a good solution. Now let's look at the third one. AWS Memcache is a multi-AZ, highly available, fast in-memory cache that can handle read queries and reduce the load on RDS. Yeah, it's true. AWS Memcache is a fast in-memory cache that can handle read queries, but it is not multi-AZ and you cannot recover from failure. So, so this it doesn't meet all the requirements, so this is not the correct answer. Now, DAX can be used to offload some of the read queries from RDS. DAX uses the write-through caching strategy to provide better performance than RDS read replica. So that is true. Our DAX is used for write-through caching strategy, and it can offload some of the read queries. But DAX is used for not RDS but DynamoDB. So this is incorrect. Now we have to choose between the first and two. So what you need to understand when you are looking at handling read queries, you have two options: read replica and, as we discussed, and in-memory cache, so elastic cache. So if the read queries are changing frequently, then a good solution is on read replica. But when the data is more static, then the better solution would be elastic cache. So in this case, as it says that the read queries are not, the changes to the read queries are minimal. So in this case, the second would be more appropriate option. Okay, great. Now let's look at the last question. A global bank has designed a high-level multi-region application to be deployed in US East and US West region to mitigate against AWS region failure. It also requires no SQL database that is highly available with good performance and fault tolerant to regional failure. So what are the key requirements? It requires a database that is NoSQL database, and it needs to be deployed across two regions, and it should be able to mitigate the region failure. It should be highly available with good performance and fault tolerance to region failure. So basically, NoSQL DB managed service with we should be able to tolerate the regional failure. Now let's look at the options. So use Route 50 to distribute traffic across EC2 auto scaling group. Okay, so that takes care of the web app tier. Use RDS global tables for multi-region read and improve the read and performance across the region. This allows to continue read and write in case of regional failure with no disruption. Okay, so this is not the correct option because we are looking at NoSQL, and here it is talking about RDS. So this is not the correct answer. So we can rule this out. Second one, use the Route 53 to distribute traffic across EC2. Okay, this is pretty much same. Use DynamoDB global tables for multi-region read and write to improve the read and write performance across the region. This allows to continue read and write in case of region failure. So this seems like a very promising answer. So you have NoSQL database, which is DynamoDB, and it is saying use global tables. So what global tables can do? It can do multi-region read and write. So it can write and read across both regions, and then they can replicate async. So if one region fails, the other region can continue to do the write and read. So so that's where you use the AWS Dynamo global table. So this seems to be a very good fit for the requirement. Now let's take a look at the third one. Use two fixed endpoint global accelerator to route the traffic to LVs and use RDS MySQL for automatic cross-stage fail. Again, you can use the global accelerator, but this doesn't seem to be correct answer because you have RDS, and what we're looking at is NoSQL database. Then the final one is use two fixed endpoints global accelerator traffic to LV and use RDS MySQL to cross-region replica that automate failover to another region which has the read replica. The primary and read replica will continue to sync across the regions. So now in this case, you can see you have the global accelerator for two LBs, which is okay. Then you are using the RDS MySQL for cross-region replica. Again, I mean, this is not a correct answer because you are looking at a NoSQL DB. But one thing you need to keep in mind is that, yeah, you can have, if it was a SQL database, then you could use RDS MySQL and have cross-region replicas, which can then you can switch over to the second region. But the RTO and RPO, as we had earlier discussed, is less than is more than 5 minutes because you have to manually switch over to another region for that read replica, and at the same time there is also a replication lag. Okay, that's pretty much it from on this topic. Thank you very much.